An electric dipole has a charge of 2 microcoulomb separated by a distance of 4 cm. At what distance on the equatorial line will be the electric field intensity be? This much value here. Okay, so they're talking about electric dipole has a charge. So let me draw here dipole. Okay, so since we know in the dipole the magnitude will be same only here. Okay, so let me write here, this is negative microcoulombs and this is positive 2 microcoulombs. The magnitude will be same but the charges will be opposite. Okay, and separated by the distance. So the distance between these two charges is how much? That is 4 centimeter. Okay, yes, done. At what distance on the equatorial line? So we are talking about the equatorial line here, so that will be, I need to draw a normal. This is what center. Okay, this is okay, line will be the electric field intensity. So the electric field intensity which is applying on this here is the this is the test charge. Okay, okay, and the distance they are asking us to calculate here. At what distance? So that is r, which is equals to what? Question mark here. Okay, now so in this question what and all they've given, they're given the q which is equals to 2 microcoulombs. Okay, and we need to convert to the coulomb. So what we need to do, we need to multiply it by 10 raised to the power negative 6 coulombs here. And the distance, this actually in the dipole we will write it as a 2l, which is equals to 4 centimeter. Okay, since we need to convert to the meter, so we have to multiply it by 10 raised to the power negative 2 and it's become a meter now. Now to for the electric field for the equatorial, what we are having the formula, electric field for the equatorial, that we are having formula, that is k for the coulombs constant multiply with the dipole moment over r cube here. Okay, now we need to rearrange the formula for the r here. R cube which is equals to, will be having k p over electric field in the equatorial here. Now let us start substituting the values. This is 9 into 10 raised to the power 9 Newton meter square over c square. Now this Planck's constant we need to calculate, that is nothing but distance and the magnitude of the charges. Okay, distance between the charges multiply with the charges here. So here it is distance which is 10 raised to the power negative 2 meter and the charge, that is 2 into 10 raised to the power negative 6 coulombs here. Now 4 times 2 is 8 and here 10 raised to the power negative 8 coulomb meter. Okay, this value now we have to substitute here, that is 8 into 10 raised to the power negative 8 coulomb meter here. Okay, now what is the equatorial value we are having? That is, I forgot to write, this is, let me write here, electric field in the equatorial, that is 1.125 into 10 raised to the power 4 Newton over coulomb here. So let me write, that is value here into 10 raised to the power 4 Newton over coulomb here. Now see here, from this what and all we can do cancellation. Here from this 1c and this 1c it will get cancelled, and this c and this c it will get cancelled, and this Newton and this Newton it will get cancelled here. Okay, now we need to multiply 9 times 8, that will be 72 into here 10 bases are same, so what we can do, we can simplify this. So I'll be getting 1 here, so I'm simply writing, and here m square into m, that will be m cube. Okay, now look at the denominator, this 1 point it is there. Now I'm going to write it as a 1125 over, this is 1000 multiplies this 10 raised to the power 4, I'm just writing it as a 10,000 here, and here what we left, m cube, that's it. Okay, now this 30 and this 30 get cancelled here, and this 10 it will get cancelled, so we left with the 72 over 1125. So when I'll simplify, when I'll divide it, I'll be getting answer as a 0.064, and here it is meter cube. Okay, and the left side what we are having, that is r cube, right? We are having r cube. Now this cube I'm shifting to the right side, so I'll be having cube root of 0.064 m cube. Okay, now this cube root what we can do, we can split for the both. So in that case I'll be having cube root of 0.064 multiply cube root of m cube. Now from this cube root and this cube it will get cancelled, so we left with only m, and when we will find the value for this, we'll be getting answer as a 0.38, or we can just write it as a 0.4 meter. So this is what r value. Okay, so it means the distance between the center of this charges and this test charge is how much, that is 0.4 meter here. Okay.